In this video, you will learn how to build RAG AI agents for free, so you do not have to deal with n8n subscriptions or OpenAI subscriptions. And for us to test this out, let us send off a very generic message which says, what is the remote work policy? Now, before we send out this message, I want to disconnect the vector store, right? I also want to open up this AI agent, remove the system message that is pointing into that vector store. So I want to test sending this message to only the AI agent that has Ollama chat model and the response. They will compare it to when we add the RAG out of it to this AI agent. So what is remote work policy? This is a fairly generic message. Let's see what it's going to get back. So you can see this is a very generic response. There's nothing specific about it. It just basically gave us something from its own knowledge base. This is where RAG comes in effectively. So this time around, I want us to feed our company policy to this vector store. Right, so now I'm connecting it back, and I'm going to add a message to it so that I can call the vector store. Then, of course, we have a company document, right, with the different remote work and hybrid policy. So let's go back there. Let's save this, refresh it. Then let's ask the same question. What is the remote work policy? Exactly the same question. But this time around, this is now a RAG AI agent. Let us see the response it's going to provide to us. Okay, now that we have the response back, you can see that it has a more concise response. Based on the provided information, it appears remote work policy requires the manager approval. Additionally, company equipment provided for remote work must be used responsibly. So it basically just gave us, if we go back to the document on the remote work policy, you can basically see this is almost like this, basically the same thing that's in the document. It didn't just provide generic information, it provided data based on the company policy, which we have already ingested into the data store. So I'm going to start from the very beginning and walk you through note by note, step by step on how you can build something like this. So before we jump into this, I need to explain what RAG is in the first place. So RAG is basically an acronym for Retrieval-Augmented Generation, right? So basically you're retrieving an augmented information. And the way it works is normally when you send a query to an LLM, maybe OpenAI or Perplexity or any LLM, or you're using ChatGPT, what happens is that you send off this query, the LLM processes it and generates a response for you. So that's basically how it works. Now, for RAG, because the LLM may not have company-specific information or data that is specific to you, they were not trained on data around maybe your processes, your HRO policies, your company policies, and you want people to be able to retrieve those kind of data for your own use case. That is where you then include RAG in the AI agent workflow. So the workflow will then become something like this. The user still sends a query. The query goes to the LLM. This time around, the LLM takes the prompt, takes the user's query, and uses it to search the vector store to look for things related to what you ask. And I'm going to break this down a lot further as we go on. It's going to get that information. It's going to retrieve the relevant data. After retrieving the relevant data, it generates an augmented response for the user. That is why it is called RAG, Retrieval-Augmented Generation. Now, this information in which it is using to augment whatever it is generating for you is typically stored in what we call a vector store. So that's where that data is stored. Now, the question is, how do we get the data into a vector store? So assume you have a company policy document and you want to provide that policy document to your LLM so that your users may be able to access it. The first thing you do is you go through a process called chunking. Now, in chunking, it takes those text in that document and breaks it down into different chunks. So it might be 200-word chunks or 500-word chunks, but it takes it and breaks it into different chunks. After it has done that, it loads it into an embedding model, right? That embedding model is basically what it's basically doing is that it's converting the text. It may be text, it may be images, but whatever is in that document has been broken into chunks. It is converting it into its numerical representation. Then it then stores it as vectors in a vector store. So this is a high-level explanation without going into much details. But I saw this on LangChain website and I really loved this graphic. You can see you load your document, it's splitting it into chunks, then it creates those embeddings which are like a numerical representation. Then after it has created those embeddings, it stores it in a store which is called a vector store. So they become vectors stored in that vector store. So this is a high level overview of how the RAG works. So let's go in and let's build out this workflow. Now, before we start the implementation, it's important for us to have downloaded the self-hosted AI starter kit. Now, in a previous video, I explained how to download this self-hosted AI starter kit and have it installed. You should have your Docker operational. You should have your starter kit operational. Now, this starter kit has the self-hosted n8n. It has the Ollama, which is what we are going to be using as our free LLM. It has the Qdrant. The Qdrant is going to be our open source vector store, which is free, and we also have the Postgres SQL. In the previous video, I showed you how to use the self-hosted n8n and the Ollama. In this video, I'm going to be breaking down how you can use the vector store. So let's jump right into it. So let me save this, and I want us to start it from the very beginning. Create a new workflow. So in this particular scenario, what is going on is that the document, it has been loaded to your Google Drive. So the first thing we need to do is to be able to pull that document and convert it into vectors. So the first thing, let's look for the drive, G drive, trigger on changes involving a specific folder. We select that one. So what this is going to be doing is going to be polling, let's say, check every day. If there's a new document, download that document and run it. So here you have your credentials to connect. If you don't already know how to connect your credentials, kindly go through my previous video and you'll be able to get that. From the list, we open the list of the folders. Company docs, that's the folder we are looking for. Watch out for when file is created, file updated. We can say maybe when a file is created. So yeah, maybe a new file has been added, get it and let's run it. So if I do a fetch test event, it's going to check that folder and it's going to retrieve, it's going to say, oh, a file has been created. This is the file that has been created. Now I want to add another G drive node. Now what this node is going to do is that it's going to download the file. So this is the G drive, the resources file. I want it to download file. Here I always like to use by ID, so that because for every document it has its own ID. So I'm going to grab the ID here and dump it here. So if a different document is going to just grab that document. So if I execute this file, it's going to download the document and it is a binary. You can see the binary here is highlighted. So that brings us to the next node, right? The next node is now the vector. In this particular case, we are using Qdrant. We are using the Qdrant vector store. So for the Qdrant vector store, we are going to say retrieve documents. Just take anyone, add documents to the vector store. Because if you select anyone, you can always change it here, right? So I want to insert documents into the vector store. That's what I want to do. So now that we are at this point, you need to have access to the collection in your Qdrant. Remember, this Qdrant is one of the things we downloaded in the self-hosted AI starter kit. So to access this Qdrant collection so that we can create our own collection, you open up your Docker container. Again, you should have installed this. You open up your Docker container. You come to under containers here. You look for Qdrant. You see here, you tap on this icon. It opens up this page. Usually, it will be blank like this. Just put slash and put dashboard here. That will open it up for you. So once it opens it up for you, it gives you the opportunity to create collections. I already have several collections here, but we can walk through it so that I can show you how to create a collection. So enter a collection name. I can say n8n demo, right? If you say continue, global search, what to use the search for, you can select simple embedding, vector configuration. Of course, you have to choose your vector configuration. And we always suggest you use your 3072, right? This is what it's going to use. This is the model it's going to use for the embedding. Then choose metric is always, usually most people use cosine and dot, but you can just go ahead. Because we are doing similarity searching here, use cosine, that is better for that. Then if you want to add indexes, you can go ahead and add indexes. But at this point, you have completely created your collection. So you can see this n8n demo and you can see the status is green. So if I come back to this place and I open this up, you can see the n8n demo. Every other thing looks good. We open this up. The next thing is to add the embedding model. We are still going to use the Ollama, which is open source. Select the model as 3.2 latest. The next thing is to add the document loader, default data loader, which is what does the chunking. Now be very careful here. The type of data here is JSON. Right, that's the default, but you need to change it to binary because your input here is a binary file. So you need to select this as binary. XSplitting is simple. Yeah, that works. Now we are ready to then load that document. Remember, we have downloaded it from G Drive. Now we want to load it into our vector store. So I'll just execute this. It will pick up that document. First of all, it will chunk it. Then it will send it to the embeddings for the embeddings model for it to be converted into the numerical representation. After that is done, it is then going to store it in the vector store, the Qdrant vector store, which is an open source vector store that is for free, that you can use for free. Now, you should also know that the speed of this configuration is going to be dependent on your hardware. I mean, the speed of the workflow will be dependent on the hardware you're using. So it is complete. If we go back to the collection, the Qdrant, you can see here, let me refresh this. You can see that the points here is now 9, right? So if you open this up, let's open this up, you're going to see the content. You can see introduction. This handbook outlines the rules, benefits, and standards for highlight. Basically, this is the document, right? Introduction, this handbook outlines the rules, benefits, and standards that govern deployment at highlight. So that is basically what you're going to have there in the data store, in the vector store rather. You're going to see it's broken them into different chunks. Now that we have it in our vector store, the next step is to create a workflow that extracts that data. So we come back to this, please, and look for our AI agent node. Bring out this node. It should have a connected chat trigger. Then here we need to add what will be. So if we open this, if we click out of this place, you have the AI agent. We still need our chat trigger. So let's include our chat trigger. So we connect this. Now we have this AI agent. We need to add a chat model. We use the Ollama again, which is our open source chat model. We select 3.2 latest. That is our chat model. Now you have this AI agent. Now we need to add memory. So for memory, click on the memory. You can select the simple memory. Then for the tool, you can come back here. Now we need our vector store, right? Qdrant vector store. We'll bring it up. So this is the vector store. This is the same vector store in which we loaded our document. So we need to access that vector store. So if you open it up, you need to tell it retrieve documents. Let's write it there. Retrieve docs. Then we need to choose from the lists n8n demo. So that's the vector store we created, the collection we created for that vector store. Then we click out of this place. You need to use the same embedding. So I can drag this here and tell it to go and use the same embedding. Now, it's advisable to always use the same embedding. Don't create a different embedding so that your results are more accurate. Now, we have this full AI agent, fully operational. So we can decide to ask a question to say, workplace conduct, what is the required workplace conduct? So this is going to go to the RAG AI agent. Then the RAG AI agent is going to combine the prompt and the user's message. It's going to create embeddings from that. Then it's going to use it to do a similarity search to the vector store. Then the information will be returned to this Ollama chat model, which then summarizes it using this RAG AI agent and presents it back to you. So we have our response now. What is the required workplace conduct? It says the required workplace conduct is professionalism, acting with integrity, respect, and professionalism in all workplace interactions. So if we go back to our document, you can see that's exactly the same thing. Employees must act with integrity, respect, and professionalism in all workplace interactions. Oh, well, I was expecting it to add all this, but you get the point, right? Which RAG is able to give you more company-specific information. So this is basically retrieval-augmented generated data for you. Thank you very much for watching, and see you in the next video. Bye.